Inside this lesson, we're going to take a look at Gaussian elimination. This is the process of using elementary row operations to change any given matrix into row echelon form, or REF. In general, what we're going to do is we're going to create leading ones by using type 1 operations. That's multiplying an entire row by a non-zero number. Also, we're going to create zeros underneath our leading ones by using type 2 operations. That's adding a multiple of one row to an existing row. So the best way for me to explain the Gaussian elimination procedure is probably through a couple examples. So let's take a look at this 3x3 matrix and we'll work through the procedure together. In order for this matrix to be in row echelon form, we require that this first entry, this number 2, be a leading one. So I want you to take a moment to think about how we could change row 1 so that we have a leading one in that position where the 2 is. Yeah, so the easiest way to change that number 2 into a leading one is to use a type 1 operation where we divide the entire row 1 by 2. And if we do that, we're going to get a new matrix that looks like this. 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. And negative 4 divided by 2 is negative 2. So here's our new row 1. There are no changes to row 2, so I'll write in 0, 1, 3, and there are no changes to row 3. So I'll write in 0, 0, 1/2. Awesome, so the only thing that's preventing us now from being in row echelon form is this 1/2 down here. So the last thing we're going to do is take row 3 and multiply it by 2. Okay, in doing this operation, there's no change to row 1 or row 2, so we still have 1, minus 3, minus 2, 0, 1, 3. And we just multiply all of the numbers in row 3 by 2. So we'll have 0, 0, and 1. And you can check that this matrix satisfies all of the requirements to be in row echelon form. So let's work through another example. In this example, we're going to have to do a bit more than just multiplication of rows. So here we're also going to have to use some type 2 elementary row operations. Okay, so first things first, take a look at your first row and see if you can figure out an elementary row operation that's going to change this 1/4 into a 1. The first operation we're going to do is 4 times row 1. And when we do that operation, we end up with a new matrix that looks like this. We'll get 1/4 times 4, that's 1. 3/4 times 4, that's 3. And negative 1 times 4 is negative 4. Now we haven't made any changes to row 2, so I'm just going to copy down row 2, that's minus 1, and 2. Now that we have a leading one in this first spot up here, this 1, 1 entry, what we have to do is we somehow have to create a 0 down here. And in order for us to create zeros, we have to use type 2 operations. So specifically here, I'm going to be taking row 2, and I'm going to be adding or subtracting a multiple of row 1. In this case, row 2 plus row 1 should do the trick. Okay, and I want you to take a look at what we're going to get when we do this operation. So here we're going to take the value of row 2, which is minus 1, and add to it 1. So we get minus 1 plus 1. That's going to give us 0. Next, we have minus 1 plus 3. That's going to give us 2. And then finally, we have 2 minus 4. 2 minus 4 will give us negative 2. So there's our new row 2. We haven't done anything to change row 1, so I'm just going to copy down those values once more, like this. Okay, next up, we need to try to figure out how to change this value into a 1. We're going to have to use a type 1 elementary row operation. Now the nice thing is all of these values are divisible by 2, so let's go ahead and multiply by 1/2. Remember, multiplication by 1/2 is the same thing as dividing by 2. So I've gone ahead and I have divided row 2 by 2 to get us the new row 0, 1, minus 1. And you can go ahead and check that this final matrix here is in row echelon form. So to close up this video, I just want to note a couple of things here. The first one is when we use the Gaussian elimination procedure, we're going to end up with what we call row echelon form. And the important thing to remember here is that row echelon form is not unique. This means that if you and the person sitting beside you do different operations to get to row echelon form, your REFs might look different. So a big question that comes out of this idea that REF is not unique is it possible for our simplified matrix to be unique? And the answer is yes. We're going to take a look at the unique form, which is our REF, in the next video. Alright, my little epsilons, stay positive.